Imagine a time long before Earth, before the Sun, before even light itself danced freely through space. The universe was dark, unimaginably dense and impossibly young just moments after the Big Bang. Somewhere in that newborn chaos, particles collided, stars were born, and from the ashes of ancient explosions, a new entity began to form, the Milky Way Galaxy. Not with a bang, but with a whisper of gravity curving space, pulling in matter, and crafting what would one day become the vast, spiraling home of our planet, our sun, and us. Take a moment to picture it. There were no galaxies as we know them, just clouds of hydrogen and helium swirling aimlessly through the black. Billions of years ago, amidst these primordial tides, gravity began doing what it does best, attracting. Small clumps of matter began sticking together, forming the earliest stars. And then something incredible happened. Those stars, bound together by gravity's invisible hand, began to cluster. That loose collection would become the seed of a galaxy. Fact hash 1. The Milky Way is staggeringly ancient. Scientists estimate it to be over 13.6 billion years old, forming just a few 100 million years after the Big Bang. That means our galaxy is nearly as old as time itself. But galaxies aren't born fully grown. The Milky Way wasn't the spiral beauty we know now. In its infancy, it was raw, rough, and chaotic, a cosmic construction zone filled with furious activity. Fact hash 2. At its birth, the Milky Way was not the massive, majestic structure you see in illustration. It started as a small, irregular clump of dark matter and gas, gradually coalescing into something more organized. In those early days, gravity pulled together the ingredients for stars: hydrogen, helium, and tiny amounts of lithium. This gas began contracting under its own mass, getting hotter and denser until, boom, the first stars ignited like candles in a long, dark tunnel. Fact hash 3. Some of the oldest stars in our galaxy still exist today, hidden in the outskirts of the Milky Way's halo. These ancient stellar fossils are over 13 billion years old, born shortly after the galaxy itself. Now, here's the exciting part. The Milky Way is a cosmic Frankenstein. It wasn't born whole. It was built from pieces. Fact hash 4. Our galaxy grew not only by forming new stars, but by swallowing other smaller galaxies in colossal cosmic collisions. This process, known as galactic cannibalism, is still happening today. Imagine two cities drifting slowly toward each other, buildings merging, highways clashing, and people mixed together. That's what galaxies do. Over millions or even billions of years, the Milky Way didn't just grow, it absorbed. Fact hash 5. It's estimated that over a dozen smaller galaxies have been eaten by the Milky Way, and some are still being torn apart in real time. Looking deep into the halo surrounding our galaxy, astronomers have discovered streams of stars that didn't belong to us. They are, quite literally, the shredded remains of previous galaxies, ghost trails across the sky. Fact hash 6. These stellar streams are the cosmic fingerprints of destruction, rivers of stars stripped from doomed galaxies caught in the gravitational web of the Milky Way. But there's a mystery that defies all logic. If we account for all the stars, planets, gas and dust in our galaxy, there's something missing. It's too light. Fact hash 7. Scientists believe that nearly 85% of the Milky Way's mass is made of dark matter, a mysterious substance that doesn't emit light or energy, but exerts gravity on everything around it. We can't see dark matter, but we feel its presence. It's like a ghostly skeleton that holds the galaxy together, strengthening its gravitational grip and allowing it to form into the majestic spiral structure we observe today. Fact hash 8. The Milky Way owes its very existence to this invisible mass. Without dark matter, the galaxy would fly apart, unable to hold itself together as it rotates. The story of our galaxy isn't linear. It's layered with drama. Buried in its oldest stars and halo structure are remnants of a time before order, before spirals, before suns like ours existed. Fact hash 9. One of the stars in the galactic halo, named Smrs SJ 313 6708, may be the oldest known star ever discovered, a direct descendant of the very first stars in the universe, born from the ashes of ancient supernova. And yet, while all this is astonishing, it's not static. The Milky Way is still alive. It's still consuming, expanding, changing, breathing in galactic terms. Fact hash 10. Even now, the Milky Way is in the process of absorbing the Sagittarius dwarf galaxy, pulling it apart and wrapping its stars into our spiral arms like a cosmic embrace. From ancient beginning to modern mystery, the Milky Way has been writing an epic for billions of years, and we're just beginning to read the first chapters. So the next time you look up and see the faint trail of light splashed across the night sky, know this: you're not just seeing stars. You're seeing the history of everything. The galaxy you live in is not a random cloud of stars scattered through space. It's a swirling, majestic masterpiece with structure, rhythm, and astonishing design. If we could rise far above the plane of the Milky Way and look down upon it, what we'd see would take our breath away. A glowing spiral of stars, arms unwinding into the darkness like the twirls of a cosmic hurricane, stretching across 100,000 light-years of space. And believe it or not, we're right in the middle of that grand design, quietly orbiting one of billions of stars like dust motes lost in a cathedral of light. Fact #11. The Milky Way is classified as a barred spiral galaxy, meaning it doesn't just have a classic spiral shape. It has a central bar-shaped cluster of stars running through its core like a spine from which the spiral arms extend. This bar is not just for decoration. It plays a dynamic role in the life of our galaxy, acting like a conveyor belt that funnels gas toward the center of the galaxy, feeding star formation and activity near our central black hole. Fact #12. The Milky Way's majestic arms, those brilliant trails of stars that define its shape, aren't solid. They're gently moving waves of increased star density that rotate around the center. They're not like the arms of a spinning record. Instead, they're more like slow-moving traffic jams of stars, regions where gas and dust get compressed, triggering starbirth. When the stars form, they shine brightly, which is why the arms glow in visible light. Fact #13. The Milky Way contains 4 major spiral arms: the Perseus arm, the Norma arm, the Scutum Centaurus arm, and the Sagittarius arm, along with smaller spurs and offshoots. And here's something personal. Our own solar system lies not in one of the massive primary arms, but in a smaller, less famous branch. Fact #14. Earth, the Sun, and all the planets are located in a tiny spur called the Orion Arm, or the Orion Cygnus Arm, nestled between the Perseus and Sagittarius arms. Like a cosmic side street off a major galactic highway, the Orion Spur is our quiet little corner of the galaxy. Not too crowded, not too barren, just right. Look even closer at the heart of the galaxy, and things get even stranger. Fact #15. The center of the Milky Way contains a dense bulge of stars that takes on a 3-dimensional peanut-like shape. This central bulge is made up of older, redder stars, packed tightly in the galaxy's core. The bar and the bulge together anchor the galaxy's structure, shaping its dynamics and affecting the way stars move throughout the system. Then stretching out from this core, the spiral arms unfurl. Fact #16. The Milky Way spans a diameter of about 105,000 to 120,000 light-years, meaning light would take over 100,000 years to travel from one end of the galaxy to the other. That's staggering. You could send a beam of light at the fastest speed in the universe, and it still couldn't cross our galaxy in a human lifetime, or even in 1,000 lifetimes. And yet, despite its grandeur, we can't even photograph the Milky Way from the outside. Fact #17. We've never seen the full Milky Way from above or beyond, because we're inside it, like standing in a forest trying to view the whole from within. We can only map it using star positions, radio waves, and infrared imaging. Our view is blasted and smeared by interstellar dust, which blocks visible light and makes mapping the galaxy a puzzle worthy of generations of astronomers. But it's getting easier, thanks to space telescopes and creative methods of detection. Fact #18. The spiral arms of the Milky Way are not made of the same stars permanently locked into place. Instead, they operate more like waves, with stars drifting in and out over time. Think of the arms as traffic jams on a highway. The car's stars move through the jam, but the jam itself remains in place as long as the build-up continues. Fact #19. These spiral arms are massive stellar nurseries, places where clouds of gas are compressed and new stars are born constantly. Our solar system likely formed in such a nursery over 4.5 billion years ago in a small clump of gas inside one of the spiral arms, later drifting to the quiet neighborhood where Earth now resides. And though the arms may seem like thin pinwheels, that's an illusion of scale. Fact hash 20. The Milky Way's spiral arms are thousands of light years wide, with stars, planets, nebulae, and giant molecular clouds forming an ever-evolving structure that defines the beauty of our galaxy. From far away, the Milky Way would appear as an elegant, rotating spiral of white and blue light. But up close, it's a churning sea of birth and death, stars forming and exploding, black holes feeding, and galaxies colliding in slow motion. And here we are, one tiny solar system spinning silently in a celestial pinwheel, proof that the universe has a way of hiding incredible design inside what feels like endless chaos. Every 230 million years, our sun completes a single lap around the Milky Way, just one. That means since its birth, about 4.6 billion years ago, the sun has only made 20 orbits around the galactic center. To put that into perspective, the last time we were in this same spot in the galaxy, dinosaurs had not yet walked the Earth. In fact, Earth itself didn't even exist. Welcome to the sun's cosmic road trip, a journey so vast, so silent, and so slow that every inch is measured in millions of years. Fact 21. Our sun orbits the center of the Milky Way at an average speed of 514,000 miles per hour, 828,000 kilometers per hour. Yet, even at that speed, it takes 230 million years to complete one orbit. You might think of the sun as sitting still, a steady center for our solar system. But in truth, it's moving through space at breathtaking velocity, dragging all the planets along for the ride, including Earth. Fact hash 22. This grand orbit is called a galactic year. Earth and our entire solar system have travelled only about 20 galactic years since the sun's formation. It's mind-bending to realise that in each galactic year, civilizations rise and fall, continents drift, and entire species come and go. Humanity as we know it has been alive for only a tiny, barely measurable fraction of a single circuit. Fact hash 23. During our sun's galactic orbit, it doesn't just move around the center in a flat disk, it actually bobs up and down through the galactic plane, like a horse on a carousel. This motion is caused by the gravitational pull of other stars and the dense mass in the galactic center. Fact hash 32. Many stars in the galaxy are not alone. About half of all stars are in binary or multiple systems, where two or more stars orbit each other in complex, cosmic waltzes. These star systems can be incredibly dramatic. Some stars steal material from their partners, some die in double explosions, and some even orbit so closely they touch, merging into new massive suns. Fact hash 33. The largest known star, Ice Scuti, is a red supergiant that could fit over 1,700 suns inside of it. If it replaced our sun, it would stretch past the orbit of Saturn. In contrast, some stars are tiny but incredibly dense. A teaspoon of a certain type of dead star could outweigh an entire mountain. Fact hash 34. After a massive star dies, it can collapse into a neutron star, which is so dense that a single teaspoon of its material would weigh over 1 billion tons. And then there are the extremes, stars that spin thousands of times a second, blink on and off like lighthouses, or roast their surroundings with radiation. The diversity among stars is astonishing. Fact hash 35. The most common type of star in the Milky Way is a red dwarf, small, cool, and dim, but incredibly long-lived. Some could burn for trillions of years without dying. That's much longer than the current age of the universe, making them cosmic time capsules that will outlast almost everything else we see in the sky today. Fact hash 36. Stars, like people, are born, live, and die. They form in clouds of gas shine for millions or billions of years, then either fade out gently or explode in cosmic fireworks. The most spectacular of these deaths are supernova, titanic blasts that can outshine entire galaxies for a brief moment and spread vital elements across space. Fact hash 37. Every atom of iron in your blood was forged in the heart of a massive star and scattered across the galaxy during a supernova billions of years ago. Yes, quite literally, we are made of stars, and the recycling of that stardust into new stars and planets is what makes all life possible. Fact hash 38. New stars are born in nebulae, vast clouds of gas and dust, also known as stellar nurseries, where gravity pulls material together until new stars ignite. You may have seen these nebulae in Hubble photos, beautiful, colourful clouds shaped like pillars, waves, or spiders. Each one brims with young stars still glowing in the womb of their birth. But not all stars are friendly or stable. Fact hash 39. There are rogue stars in the Milky Way, solitary high-speed stars ejected from their systems or shot across the galaxy by powerful gravitational encounters. These stellar outcasts can travel at hundreds or even thousands of kilometers per second. Aimless wanderers through interstellar space. Fact hash 40. Just like our Sun, many stars are orbited by planets. In fact, astronomers now believe that nearly every star could have at least one. This realization has reshaped astronomy and our understanding of the galaxy. With hundreds of billions of stars in the Milky Way, there may be just as many, if not more, planets. Think of it. Every star you see at night may have its own system, its own version of Earth, its own life forms looking up at their night sky, wondering the same thing we are. Stars are not just pinpricks of light, they are furnaces, creators, companions, and sometimes destroyers. They light up our skies and give us life, and in their death, they shape the future of everything that comes after, and they are everywhere. At the exact heart of our galaxy, hidden behind veils of dust, cloaked in radio waves and surrounded by a frenzy of stars, lies a secret both terrifying and awe-inspiring. It doesn't shine, it doesn't flicker, it cannot even be seen directly, and yet it holds together the entire Milky Way. This invisible force is so powerful that not even light can escape its grasp. It's the ultimate cosmic mystery. A supermassive black hole known as Sagittarius A. Fact hash 41. At the centre of the Milky Way lies Sagittarius A, a supermassive black hole that weighs more than 4 million times the mass of our Sun. Despite its immense size, it fits within a region smaller than the orbit of Mercury. It's not some exaggerated sci-fi monster either. It's real, measurable, and it shapes everything around it with gravity alone. Fact hash 42. We cannot see Sagittarius A directly with telescopes. It emits no light. But we know it's there because it causes stars near the centre of the galaxy to whip around at incredible speeds. Astronomers have tracked these stars for decades. They've watched them loop and spiral around an invisible point, moving so fast and so close that no ordinary object could possibly account for their orbit. Fact hash 43. One famous star near the black hole, S2, completes a full orbit around Sagittarius A every 16 years, accelerating to nearly 3% the speed of light at its closest approach. It's this kind of motion, the precise, graceful dance of stars around seemingly nothing, that gave us the proof, and it's more than enough evidence to confirm that something truly massive lurks there. Fact hash 44. Black holes are formed when massive stars collapse under their own gravity, compressing everything down into a point of infinite density. A singularity. The boundary beyond which nothing can escape its pull is called the event horizon. Cross that line and there's no way back. Not for light, not for information, not for matter. Gone. Fact hash 45. Sagittarius A is not the kind of black hole formed by just one star. It's a supermassive black hole, likely formed over billions of years by devouring stars, gassed, and even other black holes. In many ways, it's the oldest resident of the Milky Way. Scientists believe it may have played a key role in organizing the early formation of the galaxy, influencing the way stars and arms took shape. Fact hash 46. The Milky Way's supermassive black hole is currently quiet, but millions of years ago, it may have been more active, flaring with enormous jets of energy as it consumed matter. X-ray echoes and gas clouds near the center of the galaxy suggest past outbursts. Ancient cosmic fireworks that would have lit up the core of the galaxy like a lighthouse made of fire and radiation. Fact hash 47. Despite its immense mass, Sagittarius A is relatively small in diameter, about 25 million kilometers wide, or roughly the size of the orbit of Venus. That's mind-bending, an object the size of a planetary orbit with a gravitational pull capable of locking an entire galaxy in place. Fact hash 48. When matter falls into Sagittarius A, it forms an accretion disk, a spiral of superheated material that glows in X-rays before vanishing beyond the event horizon. This spectacle is short-lived but incredibly energetic, often releasing more radiation in seconds than our Sun will in a million years. Fact hash 49. In 2022, astronomers captured the first ever image of Sagittarius A, using the global network of telescopes known as the Event Horizon Telescope, a blurry, glowing donut surrounding a shadow. That famous image, like a ring of light wrapped pure darkness, was a monumental confirmation that what theory had long predicted was real, the monster at the heart of our home galaxy. Fact hash 50. Though it threatens everything within its immediate grasp, Sagittarius A is not a galactic villain. It probably helped shape the Milky Way's formation and keeps stars in orbit around the core. Without it, our galaxy might not be the spiral beauty it is today. It's not evil, it's essential, a guardian of gravity, a cosmic anchor. So next time you see the sweep of the Milky Way across a dark sky, remember, there's an unseen force in the middle, cold and silent, shaping it all. The stars know. The galaxies around us know and now, so do we. In the great sweep of the Milky Way's spiral arms, there are not just stars, there are worlds, trillions of them. Some are icy and barren, others are scorched and hostile. But some might be teeming with oceans, clouds, continents, maybe even life. For most of human history, we believed our solar system was unique. But in reality, it's just one member in a vast cosmic family of planetary systems, scattered across the galaxy like grains of sand carried on a galactic breeze. Fact hash 51. The Milky Way may contain more than 100 to 200 billion planets, and possibly many more we haven't yet glimpsed. Most of these worlds orbit stars just like our Sun, while others drift alone, rogue planets untethered and drifting through space in permanent night. Fact hash 52. Since 1992, astronomers have confirmed the existence of over 5,000 exoplanets orbiting stars beyond our solar system, with thousands more awaiting confirmation. We find them using light, by seeing them dim their star as they pass in front of it, or by measuring slight wobbles in the star's movement caused by the planet's pull. Fact hash 53. Exoplanets come in all kinds of surprising varieties, including lava worlds, where the surface is molten rock, and water worlds, completely covered by deep alien oceans. Some are made almost entirely of gas, some made of ice, and some may be similar in structure and chemistry to Earth. Rocky worlds with possible atmospheres and even weather cycles. Fact hash 54. The habitable zone, sometimes called the Goldilocks zone, is the region around a star where temperatures could allow liquid water to exist on a planet's surface. Not too hot, not too cold. This is where scientists focus their searches. And we've already discovered hundreds of planets within this zone around distant stars. Fact hash 55. Some of these planets orbit binary star systems, meaning they have two suns in the sky, like the famous twin suns of Tatooine in Star Wars. Others orbit red dwarfs much cooler than our Sun, where the habitable zone is much closer to the star, possibly resulting in planets that are tidally locked, with one side in permanent day and the other in endless night. T56, NASA Kepler Space Telescope, which operated from 2009 to 2018, revolutionized our understanding of planets in the Milky Way by discovering thousands of exoplanets in just one patch of sky. Kepler revealed one staggering truth: planetary systems are the norm, not the exception. Almost every star could have planets. Most probably do. Fact hash 57. Some moons in our own solar system, like Europa orbiting Jupiter and Enceladus orbiting Saturn, may have liquid oceans beneath their icy crust, making them some of the most promising places to search for life. Even without sunlight, these moons may harbour life thanks to tidal heating and underwater hydrothermal vents similar to those on Earth's ocean floor. Fact hash 58. Until recently, scientists assumed life could only form under Earth-like conditions. Now, we know it's possible for life to emerge in more extreme and unexpected places across the galaxy. From deep ocean trenches to radioactive wastelands, life on Earth has proven surprisingly adaptable, so why not out there? Fact hash 59. Some researchers estimate the Milky Way could be home to thousands or even millions of extraterrestrial civilizations. Though distance, time, and the vastness of space could keep us forever apart, it's the ultimate cosmic question. Are we alone? And if not, will we ever find them, or will they find us first? Fact Tech 60. In the coming decades, missions like James Webb Space Telescope, Ariel, and others may be able to analyze the atmospheres of distant exoplanets detecting the fingerprints of life, such as oxygen, methane, or water vapor. What was once fantasy is quickly becoming science. We're on the edge of a revolution, one that might rewrite everything we thought we knew about life, the universe, and our place within it. In the vast ocean of the Milky Way, worlds are everywhere. Some may be desolate, some may shimmer with alien sunsets, and one at least is alive, ours. But chances are, we're not the only spark in the dark. High above and far beyond the glowing spiral arms of the Milky Way lies a region few ever talk about. Not because it isn't important, but because it's so mysterious. This is the galactic halo, a vast, nearly invisible sphere that surrounds the entire galaxy like a ghostly bubble. It's not bright, it doesn't shine, but hidden within it are the answers to some of the Milky Way's oldest secrets. Here, among drifting star clusters, ancient remnants, and something we still don't fully understand, lies a realm that could determine the fate of the galaxy itself. Fact #61. The Milky Way is surrounded by an enormous, nearly spherical halo that stretches hundreds of thousands of light years beyond the visible structure of the galaxy. Unlike the bright, flat spiral arms we see from Earth, the halo is faint, diffuse, and composed of incredibly old stars, satellite galaxies, globular clusters, and most mysteriously, dark matter. Fact #62. The halo contains fossils of the early universe, including some of the oldest stars ever formed, dating back billions of years longer than the Sun. These ancient stars drift in the halo far above the galaxy's plane, and studying them is like gazing into a cosmic museum, one that tells us how the Milky Way was built from the ground up. Fact #63. Encircling our galaxy are at least 50 known satellite galaxies, including the Magellanic Clouds, two irregular dwarf galaxies visible by the naked eye from the southern hemisphere. These smaller galaxies orbit the Milky Way like moons, and some are slowly being torn apart by its gravity, feeding their stars into the halo like a galactic buffet. Fact #64. The Milky Way halo is filled with globular clusters, dense spherical swarms of up to 1 million stars, tightly bound by gravity and among the oldest known celestial objects. Globular clusters may be leftovers from the early era of the galaxy's formation, or even relics from galaxies long since consumed. Fact #65. Most of the matter in the halo is invisible. In fact, around 85% of the Milky Way's mass is dark matter, especially concentrated in the halo, forming a hidden framework that holds the entire structure together. Dark matter can't be seen, heard, or touched. It doesn't emit or reflect light, but it reveals itself through gravity, by the way it bends light or influences the rotation of stars at the galaxy's edges. Fact #66. Without a dark matter halo, the Milky Way would fly apart. The stars in the outer regions are moving too fast for visible matter alone to keep them bound. This alone changed our entire understanding of the universe. Something enormous and hidden must be there, and not just around our galaxy, but in and around all galaxies everywhere. Fact #67. Long stellar streams, spanning tens of thousands of light years, are found in the halo. These are the remnants of galaxies that were swallowed by the Milky Way in ancient times. They're like scars on the sky, tracing ancient collisions. Each stream is a relic of a cosmic drama of creation through destruction. Fact #68. Some stars in the halo orbit in the opposite direction of the Milky Way's spin, a sign that they came from other galaxies that merged with ours. It's like finding foreign bones in a body, clear evidence of absorbed outsiders that now live inside the Milky Way structure. Fact #69. There's something called the galactic corona, a massive, hot and faintly glowing cloud of gas that also surrounds the galaxy in the halo, extending even beyond the stars and dark matter. This corona is incredibly difficult to see, but it's thought to hold as much matter as all the stars in the Milky Way combined, a missing piece of galactic mass finally found in recent years. Fact #70. The halo reaches such great distances that it reportedly overlaps with the outer edge of the Andromeda Galaxy's halo, nearly 2.5 million light-years away, meaning the two galaxies are already touching at their edges. We like to think of galaxies as isolated islands in space, but in truth they are more like clouds. Their halos brush against one another, foreshadowing a merger that is eons in the making. The halo of the Milky Way may be dim, but it is essential. It is history, mystery, and possibility, a quiet monument to ancient galactic collisions and a gravitational shell that keeps our entire galaxy intact. In a universe full of unseen forces, the halo reminds us that what you can't see often shapes everything you do. The Milky Way may seem serene in the night sky, a quiet river of stars stretching across the darkness, but make no mistake, it is not peaceful. It is a battleground, a survivor, a galactic giant forged from violence, built by collisions, and shaped by the constant pull of gravity. From its earliest moments, our galaxy has been in motion, consuming, colliding, merging, and in the distant future, the biggest collision of all is yet to come. Fact #71. The Milky Way has grown over billions of years by devouring smaller galaxies, merging them into its structure and absorbing their stars' gas and dark matter. This process is called galactic cannibalism, and it's far more common than many people realize. Big galaxies like the Milky Way owe much of their mass to centuries of feeding. Fact #72. Even now, the Milky Way is actively tearing apart the Sagittarius dwarf galaxy, a small galaxy caught in our gravity and being stretched into long streams of stars. Astronomers can clearly track the debris trail, a winding arc of stars that wraps around the Milky Way like a slowly unravelling ribbon. Fact #73. Evidence of ancient collisions is everywhere. The galaxy is filled with tidal streams, rivers of stars that are all that's left of once independent galaxies, now digested into the Milky Way. Each stream tells a story, a cosmic crime scene of a smaller galaxy pulled apart by tidal forces, its identity erased over millions of years. Fact #74. One of the most dramatic events in Earth's cosmic future is already on the calendar. The Milky Way is on a collision course with the Andromeda Galaxy, our nearest spiral neighbour. Right now, Andromeda appears as a faint smudge in the sky, but it's actually hurtling toward us at about 110 kilometers per second, or nearly 250,000 miles per hour. Fact #75. This galactic crash will occur in about 4 to 5 billion years, around the same time our Sun is nearing the end of its life. Imagine a night sky where Andromeda looms large like a second Milky Way, growing brighter each million years until stars stretch between them in a tangled, distorted bridge. Fact #76. Despite how it sounds when galaxies collide, individual stars almost never hit each other. The space between them is so vast that most stars pass right by. It's not an explosion, it's a slow gravitational ballet. Over millions of years, the two galaxies will swirl together, their shapes distorting, their stars sent flying into new orbits. Fact #77. The Milky Way and Andromeda will eventually merge into a single larger galaxy, most likely an elliptical or lenticular form. Scientists have even nicknamed the future result Milkomeda. In the aftermath of the merger, the familiar spiral arms may disappear, replaced by a more rounded structure of older stars, a new galaxy born from two giants. Fact #78. During the collision, it's possible that giant clouds of gas will crash, collapse, and trigger intense new waves of star formation, lighting up the galaxy like fireworks. Some of these stars will be short-lived blue giants. Others could form new planetary systems, perhaps even new chances for life. Fact #79. Even the supermassive black holes at the centers of the two galaxies may eventually merge, forming an even more massive black hole with unimaginable gravitational influence. This final dance of black holes will generate powerful gravitational waves, ripples in the fabric of space-time that we might one day be able to detect. Fact #80. After billions of years of turbulent transition, The newly merged galaxy will settle into a new quiet phase, its chaotic past hidden beneath the light of billions of now unified stars. And long after, in the deep distant future, Milky may become an island in an expanding empty universe, a single shining monument to the ancient union of two great galactic families. The Milky Way isn't standing still. It is part of a larger, ongoing story of galactic evolution, written across hundreds of billions of years, and whether by fire, force, or fusion, the story always moves forward. For all its wonders, the Milky Way remains a place we can't physically explore, not yet. We can't fly to its center, hover above it, or touch the distant arms of its sprawling spiral. So how do we know so much about it? How do we map the invisible, study what we can't see directly, and understand the intricate motions of stars across hundreds of thousands of light years? The answer lies in light, data, patience, and some of the most advanced technology humanity has ever built. Fact hash 81. Even though we're inside the Milky Way and can't see it from the outside, astronomers have mapped its structure, using data from light in all parts of the spectrum, not just visible light, but radio waves, infrared, X-rays and more. Like forensic detectives, scientists assemble these pieces into a full picture. Each type of light reveals a different layer of the galaxy: stars, gas, dust, heat, gravity, and even the invisible forces behind it all. Fact hash 82. One of the major reasons we can't see large parts of the Milky Way's core in visible light is because it's obscured by massive clouds of interstellar dust. Luckily, that dust becomes nearly transparent in the infrared part of the spectrum. So astronomers look at infrared light to peer into the galaxy's crowded center and beyond. Fact hash 83. The Gaia spacecraft, launched by the European Space Agency, is one of the most ambitious missions ever. It's mapping the position, speed and motion of over 1 billion stars in 3D. With Gaia's data, we can create a living digital model of the galaxy, a detailed star map that shows not just where stars are, but where they're going, how they spin and where they came from. Fact hash 84. Telescopes like Hubble and the James Webb Space Telescope helped us peer into the edges of the galaxy and even look through gaps in the dust to see distant star clusters and galactic arms. Hubble gave us unprecedented resolution across the visible spectrum, while James Webb, operating in infrared, goes even deeper, offering glimpses into stellar nurseries and the oldest corners of the galaxy. Fact hash 85. Back on Earth, ground-based observatories like the Very Large Telescope, VLT, use special adaptive optics to cancel out atmospheric blur and make incredibly sharp galactic measurements. From mountaintops and deserts, they peer deep into the Milky Way night after night, helping scientists detect motion in the stars and clues about black holes, nebulae, and planet-hosting systems. Fact hash 86. Using a method called spectroscopy, astronomers can analyze a star's light and figure out what it's made of, just by splitting its light into a rainbow and examining the tiny absorption lines. From this, we can tell a star's temperature, chemical composition, age, and even whether it's moving toward or away from us. It's like reading a barcode built into the starlight itself. Fact hash 87. A technique called gravitational microlensing allows us to detect planets in distant star systems when an object passes in front of another and bends the light just enough to reveal what's hiding behind it. This allows astronomers to discover planets that we can't see directly, including gas giants, Earth-like planets, and even rogue planets drifting alone through the galaxy. Fact hash 88. Probes like Voyager 1 and Voyager 2 have now left the heliosphere, the invisible bubble created by the Sun, entering interstellar space where the influence of the galaxy begins to rule. They carry instruments still collecting data, giving us our first direct measurements of what it feels like to be outside the solar system, the very edge of the Sun's reach. Fact hash 89. The breakthrough detection of gravitational waves in 2015 opened a new way to study the galaxy by listening to the ripples caused by massive collisions like black hole mergers and neutron star crashes. Gravitational wave astronomy doesn't rely on light at all. It measures distortions in space-time itself. This revolutionary method will help uncover hidden events in the Milky Way we could never have seen before. Fact hash 90. Almost everything we know about the Milky Way was learned through light that is millions or even billions of years old, meaning that when we look out into the galaxy, we're looking back in time. Light we detect today may have left its source before humans existed. In fact, by the time it reaches Earth, the star it came from might already be gone. Studying the Milky Way is like unlocking a cosmic time machine, and every star is a window into a different era. Though we are grounded on one small planet in a single solar system, we have found ways to stretch our senses across the entire galaxy. Through creativity, technology, and tireless curiosity, humanity has begun to map the unimaginable. The more we uncover, the more we realize how much remains hidden, waiting to be discovered in the silence between stars. Someday the Milky Way will die. It won't happen tomorrow or for billions of years. But just like stars and planets and civilizations, galaxies too have life cycles. The brilliant spiral that cradles our sun will not shine forever. But before that distant end comes, the Milky Way still has a future rich with motion, transformation, mystery, and the potential for discoveries that could redefine what it means to be human. Fact hash 91. Over the next few billion years, the Milky Way will gradually run out of star-forming material. The gas clouds that birth new stars will be used up or blown away. Star formation will slow, then stop. No new light will be born. The spiral arms will fade. And eventually, only ancient dying stars will remain. Fact hash 92. After its collision with Andromeda, the Milky Way will likely become a giant elliptical galaxy, more spherical than spiral, with fewer bright, young stars and more red, aging giants. The fire and motion we see in galaxies today will be replaced by a quiet twilight of starlight, the golden years of a galaxy entering its final chapter. Fact hash 93. In the ultra-distant future, billions of years beyond any human calendar, the Milky Way stars will cool, fade, and go dark, leaving behind white dwarfs, black holes, and cold, dead remnants. Eventually, gravity may fling stars into empty space, or they may fall into black holes. Over trillions of years, the galaxy will empty and darken until nothing recognizable remains. Fact hash 94. If life survives, whether biological or machine, it may spread across the galaxy, claiming new worlds, building artificial suns, or harnessing starlight before it vanishes. Civilizations may rise around red dwarfs, expand into orbiting megastructures, or even burrow into planets orbiting dying suns. The Milky Way could become a network of ancient knowledge, sustained by what comes after us. Fact hash 95. One possible future includes the spread of humanity beyond Earth, colonizing other star systems, using technologies we haven't yet imagined, like fusion-powered ships or theoretical warp drives. When Earth is long gone, the Milky Way may still carry the legacy of its first thinking species, now scattered among the stars. Fact hash 96. Black holes, especially the supermassive one at the center, will likely outlive us all, enduring for quintillions of years until they slowly evaporate through Hawking radiation. As strange as it sounds, in the farthest reaches of time, the Milky Way could be reduced to just radiation and ash, slowly fading into background noise. Fact hash 97. Despite its inevitable fate, the Milky Way as we know it is still young on cosmic timescales. There's time for new discoveries, new life, and unimaginable adventures. We're not witnessing the end, we're part of the ongoing story, and our chapter may be just beginning. Fact hash 98. Future telescopes, probes, and possibly human explorers may one day chart the entire galaxy, creating detailed 3D maps, cataloguing every star and planet, and possibly finding signs of intelligent life elsewhere. Imagine a future where the Milky Way has been fully explored, not just mapped by machines, but touched by human or post-human hands. Fact hash 99. As space expands, other galaxies will drift farther and farther away. In trillions of years, even light from them won't be able to reach us. The Milky Way will become a lone island in an ocean of darkness. In that immense void, everything we know will be contained within our galaxy. its stars, its dark matter, its history, and us. Factish 100, but in this present moment, right now, we are alive in a galaxy that burns with energy, that crackles with motion, that gave us everything, our atoms, our sky, our home. We are the Milky Way made conscious, and that is a miracle. So when you step outside tonight and look up, remember, those stars are not just lights, they're whispers from across space and time. They are pieces of a story, your story, written in the language of light across a galaxy that's been waiting billions of years for someone to finally listen. And now you know 100 reasons why it's extraordinary